Okay, welcome to Math 31 notes for section 4.1. And in this section, we're going to learn the vocabulary and the concepts associated with fractions and mixed numbers. Some of the basics that will carry over into future sections dealing with this. All right, so let's start with the main terminology here. The Latin word fractus, we get our word to fracture from this. It means to break. And it's more than just that. In a math classroom, you're going to break things up into equal parts. So when you cut a candy into equal parts and eat part of that, some of those parts, you've eaten a fraction of that candy bar. Now we express fractions with a little bar typically, and the top part is called the numerator. That would be A in this example, and the B is called the denominator. So we're going to start with the role of the bottom one, the denominator. And the word denominator suggests either the size of the piece that you cut or the name of the piece that is based on that size. So for instance, if you cut a candy bar into 5 equal parts, or a hot dog in this case, then each of those 5 equal parts is called a fifth. That's what it's called. The denomination is fifths. You're going to put a 5 underneath the fraction bar to indicate that you cut the original object into 5 equal parts. The size of a cash bill is also its denomination, so we use that word in other contexts. For instance, a teller might ask you if you want your $100 withdrawal to be in denominations of 5s, 10s, or 20s. And what the person is asking you is how big the bill is that you want. Now, one of the things that takes a little getting used to is the bigger the number gets on the bottom, the smaller the size of the piece. So, for instance, if you had a big pie and you cut it into 3 pieces, they'd be very large pieces. But if that would be thirds. But if you cut it into 20ths, you're going to take that pie and subdivide it into 20 equal slices, and of necessity, those 20ths would be very slim, small pieces. So the first thing you want to know is how many pieces did you cut the original into? So we have right here a rectangle, and that rectangle is subdivided into 1, 2, 3, 4 equal-sized parts, which would then tell you that we're dealing with fourths here. And the other number that's going to be used in this section is how many of those pieces you are shading or eating or otherwise indicating. And that's called the numerator. We'll talk about that one later. So if you look at this large group of animals, what portion of these animals are ducks? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 animals, and 9 of those 15 animals are ducks. So if you think of the group, it's being divided into 15 equal parts, namely animal, 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 and so forth. And of those parts, each one being a separate organism, animal, we count 9 of them that are ducks. All right, so the top number counts, it numerates. And so if I ask you a question down here in the bottom, how many are shaded, you'll first count the ones that are shaded. In this case, there's 2, part A, there's 2 that are shaded, and the original shape was divided into 6 equal parts. So you would say that 2 of the 6th, and I say 6th with a TH on it, telling you the size of the part. It's the part you get when you divide it into 6 equal sections. 2 of those are shaded. Here, again, we're numerating or counting. 2 of them are shaded out of a total of 7. So 2/7 of the group are shaded. In the next one here, you have 4 are shaded out of a total of 8 that are equal. And you can count the 8. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 equal parts in this kind of an Argyle pattern. And of those 8 equal parts, 4 of them we numerate, are shaded. Okay, later we'll learn how to express some of these fractions in different ways. Okay, the next thing I'm going to cover is the difference between a proper fraction and an improper fraction. A proper fraction is less than the total original amount. So if you have just a single thing like a candy bar that you're cutting into pieces, or a stick, or maybe you get a string you're cutting into fractions or equal parts, if you end up with less than the original amount, you're dealing with a proper fraction, a piece of it that's less than the original amount. And if the original amount is 1, then your fraction is always going to be less than 1. And the way you think about this is pretty simple. If the parts you're counting are fewer than you cut it into, then you're dealing with an improper fraction. 11 out of 12 parts would leave one of them on the table. And so if you divided a carrot into 12 equal parts and only ate 11 of those 12, you have not eaten the full carrot, and this is less than 1, and as a consequence, it's a proper fraction. Now, the easiest way to tell if it's proper is the top number has to be less than the denominator, or the bottom number. That makes this a proper fraction. So if you're cutting something into 20ths, I'll give another example here. I'll do it in a different color. If you're cutting something into 20ths, then any number up here less than 20 will make this into a proper fraction. Okay, so as a consequence, anything other than that is called improper. So you can see here that the 7 is bigger than the 5 below it. That 7/5 is improper. 11 on top is top heavy over 10. 9 is bigger than 2. All of these are examples of improper fractions. Now I'm going to extend this list to include one where it's equal. Let's say you cut something into 8 equal parts, but you ate all 8 of them. Then it's not exactly true that you ate part of that candy bar. This is 8/8, and since they're equal to each other, it's improper. So the top and the bottom are equal. That's also improper. And in that case, that actually equals the number 1, 8 over 8. One way to think of it just numerically, proper fractions are always less than 1. Improper fractions are equal to 1 or greater. Okay, so what we're going to look at here is the next diagram, and what's important here is to realize that the unit that's being subdivided is this irregular shape that I'm outlining here. So if you look within that shape, we're dividing it into 4 equal parts, so these are fourths. And once I've decided that I'm dealing with fourths, let me zoom in a little closer. I'm going to simply count them, and if I get more than 4 of them, I know it's improper. So here's 1 of the fourths, 2 of the fourths, 3 of the fourths, 4 of the fourths. Ooh, there's more. 5, 6, 7, and 8, 9, 10, and 11 of them are shaded. 11 fourths. This is improper. Okay, and the next one is another example of this, and it's important to notice this gap between here. So you shouldn't think of this whole thing as being one object. We have 2 separate objects here, like this. And those 2 separate objects are each being subdivided into 1, 2, 3, 4, 5 parts. So these are fifths. Let me write that down. And I'm going to count how many fifths are shaded. 1, 2, 3, 4, 5, 6, 7, 8 fifths are shaded. So this is improper. The top number is bigger than the bottom number, and even if it were 5/5, if we had 5 of them, it would still be improper. Okay, moving on to the idea of a mixed number. These ideas are related to each other. Improper fractions can always be rewritten in a different format called a mixed number format. And what a mixed number format is a combination of a whole number and, in this case, we're adding a proper fraction put together. So if you look at the previous examples, example 3 was 11/4, but we could also think of it in different terms. You could think of it as this whole object and this whole object plus 3/4 extra, and we would write it like this: 2 whole objects and 3/4 extra. This is one of the only places in math where between these, two things shoved up against each other usually means multiplication, but in this case it's like adding. So this is really, if you think of it, 2 plus 3/4, and we read it with the word and. So we read it 2 and 3/4. Now on this one we have our whole object here. We get that from cutting something into 5 parts and then taking all 5 parts. So there's 1 plus the 3/5 that are down on the other end, down here, these 3/5. And so when you put this together as a mixed number, you say 1 and 3/5, and you write it like that. 1 whole object and 3/5 added to it. So I mentioned this earlier, but the numbers up against each other here are adding the whole number to the fraction, or the fraction to the whole number. So if you look at this example down here, it says 12 and 2/5. It really means 12 plus 2/5. That's the meaning of it, but we always write it as just simply 12 and 2/5, like that. But if you compare that with regular algebra, when you put things up against each other, in that context, it means times. So 5n really means 5 times n in regular algebra. Okay, I'm going to pick up on pages 3 and 4 in a separate video to keep these videos a little bit more manageable in size. You'll probably have another one about the same length following this. It'll say 4.1 and pages 3 and 4.